Now we move on now to the final operation of radicals, and that will be division of radical expressions. And you remember a guideline we talked about a while back, that you never want to leave a fraction as a radicand. Now a new guideline that we're going to have to adhere to is that we don't want to leave a radical in the denominator of a fraction. So we're going to first look at some examples involving square root denominators. And our first one is the square root of 3 over the square root of 2. Now our reasoning needs to go something like this. What we'd like to do is to multiply the square root of 2 by another square root expression so that the product will produce a perfect square. And I think you'll agree that what we need to multiply by then is by the square root of 2. But so we don't change the value of the fraction, we need to multiply the numerator by that as well. So we're really just multiplying by a form of 1, aren't we? So now what we have will be, in the numerator, the square root of 6 divided by the square root of 4. And that will yield the square root of 6 then all over 2. So we no longer have a radical in the denominator, but we actually have a real number, or a rational number more specifically. And so the process we just went through here is called rationalizing the denominator. So our final answer then is the square root of 6 divided by 2. Now for part B, can you anticipate what we'll need to multiply by here? I think you'll agree that multiplying by the square root of 6 in the denominator will produce a radical that has a perfect square. So we need to multiply then the numerator by that as well. So we'll have on the top 12 times the square root of 6, and in the denominator 5 times the square root of 36. So we have 12 times the square root of 6 all over 5 times 6, and 12 times the square root of 6 all over 30. And we can divide a 6 into the numerator and denominator, so that will leave us then with 2 times the square root of 6 all divided by 5. So again, you can see we ended up with a rational number in the denominator, not a radical. And so the final form, 2 times the square root of 6 over 5, actually has the same value, numeric value if you will, as the original problem, which was 12 divided by 5 times the square root of 6. And for our third example, we have x plus y divided by the square root of y. And I think you can see what we need to do is to multiply the denominator by the square root of y to rationalize the denominator. And so we'll then multiply the numerator by that as well. So we'll then have on the top the quantity x plus y times the square root of y, and in the denominator the square root of y squared. So we have the quantity x plus y times the square root of y all over just y. And you can see that there's nothing we can do to simplify or reduce the fraction any further. Now it would be acceptable to multiply in the numerator the square root of y times each of the terms inside the parentheses, but either this form or multiplying through would be just fine. So this then will be our final answer.